Okay, so we're going to be looking at frequency tables. So frequency tables is specifically for categorical or qualitative data and for quantitative data. Okay, so this is the ones we saw in class. We're going to have this particular, and this is business has determined that there are 7 types of possible defects in the production line. Calculate whatever the professor tells you to calculate, and this is what we're going to do. We're going to calculate the relative frequency, the cumulative frequency, and the relative cumulative frequency. And we're also going to graph it. Okay, so we have our data, and these are the defects that goes from A to G. And for example, for defect A, we have 10. For defect B, we have 70. So the relative frequency is very, very simple. We need to figure out first how much data we have, or how many defects specifically in the production line do we have. So what we're going to do is we're going to sum this one, since it's already in the table format. We can sum it up. Okay, this is the auto sum, or you can go up here, click on it, and say sum. So the relative frequency is very, very simple. It's whatever frequency you have in that in this one, for example, which is defect A. So you'll have the 10 divided by the total number. Okay, and so there is our frequency. We have 0.05 for defect A. We have about almost 50%, it's 40.45 that will have in defect B. And you can also do the same. We can sum it, and the sum has to give you 1. If you were to put it into percentage, then it'll be 100. Okay. Now the cumulative frequency, and remember the cumulative frequency is how much we have accumulated. So in defect A, do we have anything accumulated? We don't have a defect 0. We don't have a defect minus A or sub A. We don't have it. So since we don't have anything accumulated, it's going to be whatever we have, or the frequency of what we have specifically in the defect A column. It fills out our table. We don't want it to be filled out because this is in a table format. That's why it's filling it out. But now what we'll do is, what would we have as a cumulative frequency for defect B? So defect B, since it's cumulative, what we want is the accumulation of it. So we'll have the defect A, which in this case is going to be these 10, plus our frequency for defect B, which is 70. Okay, and the same thing, since we're looking at the cumulative frequency of C, it's what we have accumulated before C. That means the 70 plus the 10 of defect A and B, which in this case is this 80, plus our frequency of C. And we can do that onward. And if we want to pull down our formula, the very last number, since it's the accumulation, we should have the sum, these 200. And so we do have this 200 right there, and we know it's correct. The next thing is the relative cumulative frequency. And since it is relative cumulative frequency, we know we're going to be adding, we're going to figure out how much has accumulated, and also the relative part, which means these decimals. So we'll do the exact same thing. What do we have as a relative cumulative frequency? Well, we don't have anything, so we're just going to put what the relative frequency was for defect A. We'll erase these because these are not useful. We don't want always to equal the same thing. We want the accumulation. For defect B, it is going to be what we've accumulated from defect A plus what we have accumulated for defect B. Okay, just to clear it up, for defect C, it's what we've accumulated from defect A and B plus the accumulate. We'll add on the relative frequency of C, which is going to be this 0.4, which that's the accumulation of A and B plus the relative frequency of C. And we can fill it out. The sum of all of this, or not the sum of all of this, but the accumulation of the final accumulation of G should give us a 1. Okay, and that's correct. It equals to this one. Okay, so we have it correct. Now, how about we do this graph? This graph is very simple. It's going to be a column graph, and we can also make it into a histogram. We want to make it into a histogram because frequency usually work with histograms. We'll select the defects and we'll select the frequency. We'll go into insert, and there is an option for histogram. okay? And, ah, and we're not getting it. Let me, this is happening. Let's do it with this one first. I think it's always easier like that. Okay. If you want to make it a histogram, select it, right click, formato de datos, and the gap width. And with the gap width now we have this frequency chart. We're not getting the relative frequency. We're not getting the accumulative frequency. We are getting the frequency. And if you can see, this is a bimodal. That means it has two peaks, okay? And it is slightly skewed to the left, which would be a positive skew, okay? Now it says, how would we graph when we have variables that are within variables? The same, it is very, very simple. We're going to select our data, not the totals, just select the data, and we can have two different types of graph. And we saw this in class. We can have it a clustered column graph, and we talked about this is the way we're going to do it. It's going to a lot depend on the storytelling that we're going to be telling about this particular problem. Do you want to talk about the level of activity? We can leave it like that. If you want to really make a difference or be able to see the difference between men and women, we can switch around the columns and we can have all the data grouped into for the women or all the data grouped in for the men. We can also use, I'm going to change the graph type. We can also use the piled graph or the stacked graph. And that will also give us the information. Instead of having three clustered graphs, we're going to have for each one of the genders, we'll have the women, they'll be stacked. It's very easy to see that most of the women, just by looking at the graph, are have very, very low activity. They're sedentary. And in both, the ones who are active tend to be less of all three groups. And what's curious about this is, for example, for the men, it's not as easy to be able to tell. We kind of have to see, we kind of, because they kind of look very similar. So you could always put a label to be able to understand and say, okay, most men are sedentary, just like women, And the next one is both are very active, you have the extremes. So you have this for categorical data. Now let's go to our quantitative data. In our quantitative data, we have several things that we need to look at when we are constructing our frequency tables. So we have our data here, and it's not as easy to count as it is to count colors or as it is to count things that are with words. So here we have data, numerical data. And the very first thing that we're going to be able to, or that we need to be able to look is just at how much data we have, okay? And how much data, we're going to go with count. We'll open our parentheses and we'll select all our data to be able to find out we have 28 in this particular sample. The next thing is our minimum data. In our minimum data, our smallest number, so we'll put min, and the same thing, we'll figure out our numbers. Okay, we have 12. That's our minimum, our smallest number. Let's find out our maximum number because we'll need that for the class range. So we'll put max and we'll select it. And we have 65. 65 right here is going to be our biggest data. So our range basically goes from 12 to 65. That's how far or how dispersed our data is. Now let's look at the classes. When we look at, and we talked about this, when we looked at quantitative data, we need to be able to find out how many classes. How are we going to group them together? Because imagine having to count one by one all of these numbers, 12 to 65. It's going to be a huge table. Some might not even be represented in those 28. Okay, so what we want to group them together. How would we group them together? It's very, very simple. And I'll put all the formulas here, but it's the square root. And we're going to do the square root of the numbers, of the total numbers. So square root of the numbers, okay, of these 28 of the total. And that would give us for a 5.29. The thing is that class, you can't have a piece of class. So you need to round it. And the ideal is for you to round up, even if your very last class doesn't finish in that very last number. So it won't finish in 65, it can finish in 66 or 67, as long as the very last class contains this maximum number, okay? So you can always use the formula round up, which round up, what it's saying is round that number. If it's 5.2, it'll round it up to 6. If it's 5.1, it'll round it up to 6. If it's 5.5, it'll round it up to 6. So it will always round up, okay? Comma, 0, we don't want any decimals. So it's 6, it's a closed 6. In our class range, it's very, very simple, because our class range, and you want to open our parentheses, we're going to get our maximum minus our minimum divided by the number of classes. And these are how many, what's going to be our interval in each of our classes, okay? So the first thing is we've got, and we say class. We know we're going to have 6 classes. It's going to be 1, 2, 3, 4, 5, 6. Okay, we've already seen that. We're going to have our 6 classes. Now let's find out how big each range is going to be, or how big our interval is going to be within each class. So we're going to open our parentheses, and I said it was max minus min, close parentheses, divided by the number of classes. Okay, and here it is. Again, make sure that you rounded it up, because 8.8 is not going to give us correct our range. You can, I mean, you can, but it's not as good. We want the ideal is to have whole numbers, so it's easier for us to comprehend. It's going to be easier for our head. There are moments where you might use the decimals, and these might be with errors, or when your range is not so big, you know, in the whole range, where instead of going 12 to 65, maybe you have 1.6 to 3.8. You might use decimals there because they're very small. But the fact is, the ideal is for us to round it up, especially when we have so many numbers, okay? So I'll put round up again. Just, you gotta make sure. Put another parentheses here, I forgot that one. Comma 0, we don't want that, and we have 9. So it's a very close number. We can use decimals, just sometimes it's a little bit more complicated. You know, our brains are not that accustomed to analyzing decimals. But in this particular example, and with the context of the problem, we'll be able to define if we were going to use decimals or not. So here we are trying to find this particular data of class 1. So in our class 1, we want the upper limit and the lower limit of our class. And so our upper limit is always going to be of the first class, going to be our minimum value, okay? So it'll be our minimum value. And our upper limit is going to be that minimum value plus that class range, or that class interval, okay? For class 2, the lower limit is going to be the upper limit of the previous class, in this case 21. And the same thing, our upper limit is going to be our lower limit of that class plus our class range or interval. And we'll do this continuously. For class 3, our lower limit is going to be our upper limit of the previous class, and our upper limit is going to be that lower limit plus our class range. And you can pull this formula down by now, because we're not going to do it for all 6 classes. And you really want to make sure that you make absolute ranges. If not, you're pulling it down, it's always going to be the same thing. You don't want it, you want it to be the absolute range. So it's always taking that 9 of the class range, and there it is. So just to make sure, you have your lower limit is always going to be your minimum, and your maximum limit has to be inside of this interval of your very last class. So 65, it is within 57 and 66. The next thing is you do have this particular frequency. And this particular frequency, how do you get that? Well, there's a formula called frequency. Okay, so frequency basically, and it says data array. So we're going to get our data array. There it is. this is always good to use this data array. Those tool data arrays means the range of data that we have, and the bins array. The bins array is always talking about the upper limit. Okay. Once I click it, it's there. Here it is, all my data. If I want to sum it up, okay, if I want to sum it up, I'll get the 28, which is the same as this 28. Now let's do the relative frequency. Again, the relative frequency is fairly simple. It's our frequency divided by our total number of our population of our sample, which is this n, okay? Make sure that you are putting it as an absolute value so that we can pull down our formula, okay? Pull it down, and the sum of all of relative frequency has to give us 1, okay? Because we're dividing it to be able to say relative frequency, saying how much of the total does this class contain. For example, in class 3, between 30 and 39, we have 25% of our data, okay? 25% of our data is there. Now let's go to the cumulative frequency. And this is one we had done. It's very similar to the other one. It's how much we've accumulated. In class 1, we don't have a class 0. Since we don't have a class 0, our accumulative frequency is going to be the frequency of class 1, 6. Okay? For class 2, it's going to be what we've accumulated so far. How much have we accumulated? This 6. Okay, this 6 plus whatever we have new added to it in class 2, which is that 2. For class 3, everything we've accumulated from class 1 and 2, which is the 8, plus what we're now bringing in with class 3, which is 7. Okay, we can pull down the formula, and the number, the sum of all, everything we've accumulated is going to be the 28, which is the same as if I was to add all of these together as the n, okay? If you want to just pull a formula for the relative frequency, because we've already done that in the previous exercises, you can do so. And the sum of it has to be 1. It's the same thing as we did in the cumulative frequency, but the difference is that now we are using the relative frequency, okay? So there are other ways that we can do this. This is like the harder way to do it, or the lengthiest way to do it. We can also use in our data toolbar, we have at the very right, we have something called the data analysis, and we'll go ahead and use the histogram. And the histogram is going to give us all of this information, or most of this information. What do we need to tell it? We do need to tell it the upper limit. We need to give it our data, and we need to give it our upper limit. So this is information we are going to have to do by hand, but once we have that, we can go to histogram. We can put our input range right here. We can put our upper limits here. Since we did it in class, that's why it still has the information. And now we want our output range, and I'm going to put it out here so we can see it. What do we want? Well, I'm going to ask for my cumulative percentage, which is this, my cumulative relative frequency. And for my chart output, I want to see my histogram. So there it is. If I compare our data, our bin is this information of our upper limit. Our frequency is what our formula gave us, if you see it. And our cumulative frequency is this right here, okay? So we have the information. It was a lot quicker than doing it by hand, but it's important for you to understand it, how we come up with it, before you can actually just go ahead and use the data analysis. Up here to my right, I have my histogram, okay? I really don't like it always to the right. There it is. To be able to make it a histogram, again, select the columns, right click, go to Format Data Series, and the gap width, make it 0, so that they're together. So we can see this is not a unimodal because we have different peaks. It doesn't really necessarily 10 to 1. What we can see is that the growth of this is fairly, it is growing basically at the same rate. You know, that we don't have these big peaks. It's not exponential of these specifically, okay? So we have certain information here that we can see. We do have here that for the first class and for the very last class and for the middle class, we do have higher frequencies than, for example, class 2, class 4, and class 5. It tends to be a little bit lower, and we can later analyze this and to be able to see why. But we need a little bit more context, obviously, about the problem. So here, and I'm sorry that it's in Spanish, like I said, it was supposed to be in English, but I didn't translate it, okay? And basically it's saying we have these certain types of data all in kilograms of 80 people. You know, we have 80 people and we have all of their kilograms that we want to do. And this one, it's already being fixed. You know, we're not getting all the information. It says we want classes. We want classes that are with a 5 range, okay, with intervals of 5. That means if our smallest number, and I think our smallest number starts with 50 because it's asking us to use that first interval, 50 to 55, and so forth and so forth. So let's just do this exercise again. Let's see how close it was to it. So we have count, and we're going to select all our data here. We have 80 data, which is basically what they're telling us that we have, okay? Right there. Our minimum value, so we have our minimum. There it is. We have our maximum. So our minimum is 52. Our maximum, accident. I didn't open the parentheses, so I didn't grab anything. There's our max. Our classes, it's the square root of these 80 of our numbers. So it's telling us that our class actually should be of 9. We're not going to use 9. They've asked us not to use it, and that's perfectly fine. That can be a restriction. Let's just go ahead and do the range. The range is going to be the maximum minus the minimum divided by our classes. And we haven't, this one, I'm going to do it manually to round it 9, and this is going to be rounded up to 4. So it says that our interval should be 4. We're using 5. That's perfectly fine. So lower limit here is 50, and our upper limit is 55, and we'll go ahead and create our table. Plus 5. And our table is 80. So 83, so we don't need this one because 83 fits perfectly inside of this interval of 80 and 85. Okay, so let's go ahead and do our frequency. Frequency, our data array is this range of data. I know, too few data. And then it says, what's our bin? And our bin is going to be our upper limit. Okay, so there it is. Most of our data, or most of the way to these 80 people, and you can see it right here, is between 65 and 70. Let's go ahead and do the relative frequency. The relative frequency is, remember, it's the percentage of those, the frequency of the first class divided by the total number. Make sure your absolute values with the, if you have Windows with F4, if you have a Mac with Command T. There it is. That, the sum of all of that, and I'm gonna go ahead and sum it so that you can see, should give us 1. There it is. The same thing, cumulative frequency, it's going to be the 2, because we don't have anything accumulated so far. The cumulative frequency of class 2 would be whatever we have accumulated from the previous classes, which is 2, plus whatever that class frequency is getting. And since I'm going to pull it down for both, I'll do relative frequency, whatever I have from the relative frequency, I've added up, so I don't have anything, it'll be of the first class. Second class, what I've summed up from the first class, plus what I have of class 2. I'm gonna go ahead and pull down my formulas. The very, very last cumulative frequency should give me the 80, which is this 80, which is the sum of this, and the relative frequency should give me 1, which is the same as this one. Okay, and it says, and we've already done it, obtain the distribution of data without, we've already done this. This is our I'm sorry, of what we've had of our information. It says this table, a frequency table. Then it says calculate the percentage of people with a lower weight of 66. So it's going to be right here. Okay. Since we have classes, we can't get the real number, not with a frequency table. We can do it later on with percentiles, not a percentage necessarily, but be able to say what position it is. But right here, we can say other things. We can say, for example, how many people are under there. We could actually say, because we have this frequency, that here with the sum of these, okay, we have 75% of our data is specifically already summed up to here. But we can actually say right here that 38%, if you want to put it into percentage, right there, 38%, okay, has a weight less than 65. Okay, that's a lot. Okay, 38, because we're looking at this one because it's the class below that. Then it says how many people have a weight greater than 70, right here, okay, but less than 85, which is right here. It's these. Now, what would you do? Greater than 70, right here, but less than 85. So one of the things is we have to find out, it says less than, it says 85. So most likely that 85, I'm trying to find out where it's at. It's probably only once. I'm pretty sure it's only once. Oh, there is none. The maximum is 83. Okay, so it's going to be the sum of these. So I'm going to sum these up because I know these are greater than 70 and less than 85 because my biggest number is 83. So how much of it is it? I can sum it up together. It's right here. 25% of the people in this study have a weight that's above 70 kilos, above or below above or the same as 70 kilos, and less than 85. Okay. So that's one way to be able to do it. We'll look at scatter plot very, very quickly also to be able to see a correlation. And this is because we saw it in class. We're going to graph it. Graphing is very simple. I'm going to grab it. Here are this one is going to be my x-axis, one is going to be my y-axis. Insert, and right here, the very last graph is called insert the scatter. There's my scatter plot. I remember what we talked about. You can have a strong or a weak correlation, and you can have a positive or negative. If I was to draw a straight line and this, with my dots, if I was to draw straight lines with my dots, I can make a straight line. I'm going to try to insert here so that it's easier for us to see. Okay. If I was to draw a straight line, trying for it to be, okay, I can see that it's going upward. When it's going upward, I can say there's a very positive correlation. What does it mean positive? That means that the height, when the height goes up, the petal length should go up. It should also be longer. When I talk about having a negative correlation, you're going to see that that line, instead of going up, if you're following the dots, it's going to be going down, which would be a negative correlation. That means in this case, if the height went up, the size of the petal, the length of the petals goes down. Okay, just keep that in mind. That is a very positive or negative correlation. If there was points everywhere, and if I put a line, all the points were everywhere, there's no correlation. Okay, here also, how do I know if there's a weak or a strong correlation? Well, if I have a strong correlation, that means that most of the points are very, very close or on that line. Okay. So right here, we can add that line here. There's our line. This is an actual line. Okay. Um, if these points are very close to that line, we have a strong correlation. That means that it is very, very strong. Here we have an outliner, it's a little bit further away. If we had all of these points were like this point right here, we'd say we have a weak correlation. There's still a correlation, but it's not that strong. And we'll look at that a little bit, not in this class, but in the next class, of how it affects that correlation. Okay.